The following documentary will present the viewer with a different scenario for the original creation of the solar system. The currently accepted view of the origin of the solar system is that it originated in a thick cloud of mutually attracted particles of cosmic dust. After the sun coalesced and condensed out of this cloud of dust and gas, it slowly began to revolve around its axis, trailing a swirling disk of leftover cosmic matter round its equator. Over eons of time, this great disk of dust and gas gradually formed itself into clumps, which then began to form into solid spheres of varying sizes. These, in obedience to the universal imperative, also began to revolve around their axes, settling down into steady, fixed orbits at differing distances from their parent star. These almost circular orbits were determined according to their mass, size, and various other complex factors which we need not look at here. For all intents and purposes, what's generally taught about the solar system is as follows. The central sun, because of its size and the atomic reaction of its primary constituent elements, began to rapidly heat up and swell into a giant ball of incandescent radiant heat and light. In short, it became a star, a yellow dwarf to be precise. As its blazing heat radiated forth upon its brood of planetary offspring, they too began to undergo several changes. They began to rotate around upright axes, in doing so adopted regular spherical shapes. As the sun itself rotated, so it pulled its brood around with it along their orbits. Those closest to their parent, the barren and cratered little Mercury with virtually no atmosphere, and the Earth-sized Venus, which has a near molten surface, a very dense, poisonous atmosphere, and a massive greenhouse effect, became extremely hot and were thus incapable of sustaining life. The Earth, and probably Mars, fell within reasonably safe temperature extremes and produced biological life forms. The next, fifth planet either failed to form into a sphere or it exploded, either through some inner pressure stress or from a meteor impact. The four great gas giants, Jupiter, Saturn, Uranus, and Neptune, might possess small central rocky cores, but these are heavily surrounded by multi-layered, deep and dense atmospheres made up mainly of hydrogen, helium, and noxious refrigerant gases such as methane, ammonia, and ethane. Most of these planets possess satellites in the form of moons of varying sizes, some of which it's thought could possibly sustain primitive life forms. But there are also the asteroid belts, concentrated largely in the region of the missing fifth planet, but other groups are also present in other areas. Also, there are thousands of assorted comets which shoot across the skies and swing around the sun at various regular intervals, some following enormously long elliptical orbits, others following much shorter ones. However, the principal point is that in the view of orthodox science and astrophysics, to all intents and purposes, the orbits of these planets and moons, and even many of the comets, are permanently fixed. The only way in which any of them can be altered in any way is by the intrusion of some other celestial body, such as a large meteorite or a rogue asteroid. Otherwise, barring some external intrusions or accidents, as far as most astroscientists are concerned, all the orbital paths of the planets and moons in the solar system are absolutely set for all time and locked in permanently. And when one thinks hard about it, considering the enormous mass of even a small planet or moon, it would require an incredibly vast amount of effort to dislodge any of the planets from their seemingly eternal and predestined orbital courses as they all whirl around their parent, the huge, incalculably massive Sun. So, what we've described basically covers the generally accepted solar system model, with which most people are familiar, having been taught to believe this since childhood. Now, let's move on to a more controversial theory. This time, instead of either the sun's spinning disk of surplus matter clotting into lumps or bubbles of electrical energy being captured by the sun, let us consider the possibility that the planets were spawned directly from the young sun's own material, being flung off its equator by centrifugal force. This is basically the same concept as that proposed by Pierre Laplace, but with a few important differences. In Laplace's theory, the planets were born one at a time, as excess molten matter that had built up around the Sun's equatorial belt was thrown out periodically in blobs. At first glance, this explains the orbital spacing out of the planets very well. But what it fails to explain to me, at any rate, is why the Sun bore the four great gas giants first, or why these were rather curiously followed by 4 or 5 rocky terrestrial planets. All of this presupposes that the Sun, in its infancy, coalesced and condensed by a series of collapses out of a cloud of mutually attracted cosmic dust and gaseous material into a growing solid sphere of heated matter, and that further gravitational compaction caused it to rapidly heat up and spin at an ever-increasing rate. This would have soon caused it to form an oblate, squashed-down shape. In turn, this would have led to the rapidly forming star casting off any loose surplus molten material from its bulging equator. Eventually, as the Sun's rotary spin increased, it would have steadily become hotter, especially as it would now be attracting a rapidly growing influx of more and more cosmic dust from all directions. This would increase friction upon its outer surface and would have added enormously to its heat. This way, the Sun could very likely have begun as a molten mass of very dense matter, and that as further inner collapse occurred and its kinetic heat energy increased beyond a certain point, a chain nuclear reaction was started deep within the Sun's heart. Thus, it began converting its own hydrogen by thermonuclear fusion into helium. Thermonuclear fusion liberates energy in the form of photons, gamma rays, and neutrinos. After a great deal of internal struggle and turmoil, these eventually reach the Sun's surface, from which they're then free to escape in all directions as radiant light and heat. By the time it had reached such a stage, the Sun would have long ceased casting off blobs of molten matter, and instead would have begun to shoot forth great bursts of incandescent helium gas out of its atomic interior, via those deep vortices which we today know as sunspots. However, it's the cast-off blobs of solar matter, or plasma, that concerns us here. If the present planetary arrangement of the solar system is any guide, this excess plasma must have built up repeatedly. It would then have been flung by centrifugal force from the Sun's wide equatorial belt at regular intervals of many millennia between releases, at least to begin with. Obviously, this must have begun with what are now the gas giants. Then, as the Sun became even more densely packed, its rotary speed increased, the plasma blobs became smaller but heavier until the plasma finally ceased to be released. Now the highly compacted and overheated Sun began to undergo the deep nuclear changes which started up its inner atomic furnace and turned it rapidly into a vastly swollen, blazing star of enormous mass. The plasma blobs, still following the rotation imparted by their parent, now took up orbital paths of their own around the Sun's equator. The first to be thrown into orbit was Neptune, and he was eventually followed by Uranus. The next to be released was Saturn, followed eventually by Jupiter. We've no way of knowing just how much time passed between these releases of blobs of plasma, but the intervals would have been vast in our human concept of time. However, when considered on a celestial time scale, they probably occurred quite frequently. Then, following the births of what were to become the gas giants, the first of the terrestrial or Earth-like planets was spawned. This is the missing fifth planet, or Planet 5, that some astronomers believe exploded or met with some appalling catastrophe, the remnant fragments of which gave rise to the asteroids. The primary asteroid belt now occupies exactly the position which a large planet, perhaps 2 or 3 times Earth's size, was predicted to occupy according to Bode's law. Now we come to the planet Mars. Mars is so much smaller than Earth, being between half to 2/3 the size of our planet. Some wonder if it was actually a large moon of a missing planet, and that perhaps another rather larger than Earth-sized planet might conceivably have occupied the current orbit of Mars. If this were to someday prove to be the real truth, it then becomes a realistic proposition that our own moon, which is generally thought to be far too large to be a natural satellite of the Earth, might have been a satellite of that larger planet instead. It could easily have been sent careening out of its former orbit and been captured by the Earth's gravitational field. However, this is all pure speculation, so perhaps it might be easier to assume for the moment that Mars is in its correct and rightful place, and that there must be some odd physical reason why it remains so small, whilst the Earth and Venus have both undergone global tectonic expansion, as proposed by Carey and Maxlow. So let us, at least for the presentation of this hypothesis, leave the arrangement of the planets as we find them. In due course, the blob of matter that was to become Earth was flung into a close orbit by the rapidly swirling, still molten Sun, followed in the fullness of time by the planet Venus, which was so similar in size and mass that it and the Earth could almost have been regarded as twin sister planets. Then finally, after a slightly longer pause, tiny Mercury was cast off into space. To all intents and purposes, Mercury was essentially the runt of the litter. Each time a new protoplanet was loosed from the Sun's equator, its predecessors moved out a little further from their parent, and their orbits widened accordingly. At first, these orbits were close together, a mere few tens of thousands of miles separating them. But as they were pushed farther out by the advent of their younger siblings, their orbits began to spread further apart, each newborn protoplanet seeming to assert a physical demand for its own space. This was due no doubt to the fact that each body, being of the same polarity, was gravitationally repelled by the next. Even though these rotating blobs had not yet formed into discrete spheres, various strange physical laws had already come into play, laws which would not be discovered or defined for perhaps another 3 or 4 billion years, until man finally came upon the scene. Although even today, with all his seemingly vast technical knowledge of science and cosmology, man is yet to discover even a tenth of the wonderful rules which govern the universe. Soon after the birth of Mercury, the Sun began to undergo its great metamorphosis, as it changed from a great ball of thickening molten matter into a thermonuclear fusion furnace, fueled by its own superabundant supply of hydrogen. There are probably a dozen ways in which this might have come to get started, but start it did. And so it continues reacting and blazing to this day, and will continue to do so into the distant future, till its store of hydrogen finally peters out. Then, like a nearly consumed bonfire, it will collapse in on itself and burst forth ferociously again as a huge red giant in one final, almighty spherical explosion of blazing solar plasma hundreds of times its former diameter. But the Sun's last blaze of glory, in which its planets, if they're still there, will be totally consumed, will last only for a brief period before its last outer layers are burned away. Then its shrunken core will shrivel into a white dwarf, and as it finally cools, into a small blackened ball of frozen cinders. A wandering invisible has-been, and a dangerous cosmic traffic hazard in the lonely, inky blackness of outer space. It seems that as each new protoplanetary blob of matter was centrifuged off the Sun's equator, the one preceding it had to gradually move further out into an ever-increasingly distant orbit to make room for the newcomer. This action gradually pushed each of the planets in turn into a certain zone of temperature balance. There, the fervent heat of the Sun was countered by the zero cold of outer space, to such an extent as to permit the protoplanet to begin cooling down. This it did sufficiently for the surface crust to become solid, and some of its ejected atmospheric gases, especially water vapor, to begin condensing into a liquid form. This fell, probably mixed with other more noxious gases like sulfur dioxide, as rain, which at first never reached the still hot surface before being vaporized again. However, as time wore on and the surface rocks cooled down further, it would eventually have fallen upon them, cooling them even further still. This would allow the rain solution to be separated into water and other component chemical solids. However, it must be borne in mind that each planet, as its orbit passed through this region of space, would have produced a thick cloak of cloud layers, which would cause a vast greenhouse effect such as we now see on Venus. Venus will have to travel much further towards this critical region before its dense mass of cloud cover begins to dissipate by cooling and allows the sun's radiation to penetrate and begin working upon both atmosphere and surface. For example, looking inward from the Earth today, we see our immediate inner neighbor, Venus, still deeply covered by just such a mephitic layering of clouds. This signifies that its surface is still too hot for the falling rain to reach it before being vaporized. But at least we know that the planet itself is spinning inside its dense cocoon of clouds. Beyond Venus, however, and much closer to the Sun, we see tiny Mercury. Here's a planet that, for some reason, has lost its spin. Perhaps the iron gravitational grip of the Sun at so short a range is preventing it from doing so. It does not yet have any real atmosphere either, although a very attenuated and wispy one has recently been detected. However, it remains to be seen what will happen to Mercury as it spirals steadily further away from the aging Sun and the Sun's radiant heat also begins to wane. Who knows what results these changes might affect upon Mercury? Many scientists claim that Mercury is dead and can never be a home to life. Others say that life could possibly develop around its terminator, that region of its surface that lies between its day and night sides and widens as Mercury oscillates slightly from side to side. I personally feel that many amazing changes could still occur on Mercury before it spirals beyond the critical region. So what is this mysterious critical region? What does it signify, and what happens when a planet enters it? And how can a planet enter it anyhow? Surely they're all traveling along predetermined fixed orbits at permanently set distances from the Sun. Many scientists believe that this critical region is a very real band of space which begins at approximately 0.75 astronomical units from the Sun and extends outwards towards approximately 1.75 astronomical units. Orthodox science appears to have recently begun to acknowledge the existence of such a life zone, which they call the habitable zone, or HZ. However, before we can discuss that, we must first explain other phenomenon, namely that the planets are not traveling along permanently fixed orbital tram lines in space, but in fact are spiraling outwards away from the Sun. The reason for this is that since the Sun is feeding upon its own hydrogen content, it must be gradually consuming its own mass. This is then being radiated away into space as radiant heat energy. Thus, if the mass of the Sun is constantly being depleted, so must its gravitational hold upon the planets that orbit around it. At the same time, our own Earth, and therefore the other planets, are continuing to grow in two ways. One way is by global tectonic expansion, which is increasing their sizes and therefore their masses. The other way that all planets grow is by the continuous accretion of cosmetic dust particles and the collision of meteorites. Even those meteorites that burn up in the atmosphere must eventually descend to the surface, even if only as meteoric dust and particles. This is still accretion and will continue unabated throughout the planet's life. The region known as the habitable zone must have existed ever since the Sun first became a vast atomic furnace, since the planets assumed their current global shapes and began to solidify. The Earth is still quite well situated inside this zone, as also, but to a much lesser degree, is Mars. The planet Venus has yet to enter this region, as she's currently only at 0.72 astronomical units from the Sun, which leaves her still with 0.03 astronomical units to travel outward upon her spiraling orbit before entering the life zone. A Russian scientific paper said this outward spiraling effect has thus far carried the Earth out to 93 million miles from the Sun over a period of 4.5 billion years. So Earth's mean orbital radius, plus those of the other planets, must be increasing at a tad of over 48 miles per year. The implication or conclusion which may be drawn from the foregoing is that not only did all the outer planets also pass through the same life zone in their turn, but that the zone itself has not always been as close to the Sun as it is today. It seems self-evident that the Sun has lost a very considerable amount of its heat and its mass since the birth of the planets. So whichever of these scenarios we choose, we must acknowledge that in its youth, the Sun must have put forth much more heat and gravitation over a vastly greater distance than it does today. Thus, we find the curious situation of the life zone steadily shifting toward the Sun whilst its planets are moving away from it. This means that Venus may not take quite as long to reach the habitable zone as we might imagine. The zone itself may well be approaching Venus faster than she would approach it through orbital widening. And the same might be true for barren little Mercury in some tens of thousands of years hence. It would be interesting indeed if only we were able to return then and see what fantastic changes might have transpired upon both planets. However, if we look in the opposite direction, as Mars and the four massive gas giants, we find other amazing thoughts springing to mind. As for Mars is concerned, there remains the viable possibility that it might still be retrievable as a livable planet, even though it's approaching the outer edge of this habitable zone, or HZ. Even if there's little likelihood of man recreating an entirely Earth-like environment upon its outer surface, he can still work beneath its harsh outer shell and create a tenable and comfortable underground world within the planet. Space explorers might be astounded to find out that life is already thriving inside Mars. Hopefully, they'll soon begin to reveal its deeply concealed inner secrets. Between Mars and the first of the great gas giant planets, Jupiter, we find the asteroid belt, or one of them, as there are apparently several. These gigantic boulders and planetoids are fragments of a 2 or 3 times Earth-sized planet which once rolled around its orbit between Earth and Jupiter. Whilst the gas giants are all different in many ways, they all share certain aspects and features in common. They're all enormous compared to the Earth, and Jupiter is the largest of them all. It's 11 times Earth's diameter and has a mass nearly 318 times greater. Yet its gravity is only 2.5 times that of Earth. Jupiter has 16 known moons, which vary in size from the largest, Ganymede, 3,278 miles in diameter, only 1,000 miles less than Mars in diameter, but far more massive, down to tiny Leda, 7 miles. And these are all divided into 4 groups of 4. It's believed to have a rocky core, perhaps 2,000 miles in diameter, which is surrounded by a layer of water, ammonia, ice, a very thick layer of liquid metallic hydrogen, and pure liquid hydrogen. These in turn are surrounded by a deep atmosphere comprised of a band of water vapor and droplets, another of ice crystals, a band of ammonia vapor, then one of ammonia droplets, and finally an outer one of frozen ammonia crystals. After Jupiter comes Saturn, somewhat smaller than Jupiter, but with a magnificent ring system surrounding its equatorial belt. This is split into 6 bands and are composed of silica rock fragments, iron oxide particles, and particles of ice. They're thought to be the remnants of a large moon that approached Saturn too closely. In accordance with Edward Roche's theory on close approach limits for moons or other small bodies to their parent planets was shattered by Saturn's tremendous gravity into billions of tiny fragments. Saturn is also blessed with a family of no less than 20 moons, of which the largest is Titan, 3,200 miles in diameter. Saturn is over 9 times larger than Earth, and its mass is 95 times greater. From Saturn we go to Uranus, which is around 4.5 times Earth's diameter, but is only 14.6 times its mass. Uranus also has a ring system composed of no less than 13 rings, and again appear to be the remains of a moon that approached too closely. However, it isn't anything like as spectacular as Saturn's. Uranus also has 20 satellite moons, the largest being Titania at 1,610 miles diameter. The principal strange features of Uranus is that its polar axis is horizontal instead of vertical, so the planet appears to be lying on its side, with its north pole pointing towards the distant sun. It looks as if it has somehow been tilted by 98 degrees. Also, it rotates in retrograde direction. This might mean that instead of simple toppling over on its side, actually speaking, Uranus may have done a 3/4 topple of 278 degrees. This would produce the same retrograde spin effect. In other words, its north pole is now pointing away from and not toward the sun. Venus and Pluto also rotate in retrograde direction to that of the Sun. This could only mean that they too have experienced 180-degree topples at some point of their careers. Some scientists seem to see this as being indicative of these retrograde planets having been captured by the Sun, and thus are not real members of its family. But it now appears to be generally accepted that our own Earth has probably toppled on its axis several times already in its long history, so we can safely discount this solar kidnapping theory. Neptune is the last of these Jovian gas giants, and little was really known about it until the Voyager 2 flyby in 1989. But now we can say it has 3.8 times Earth diameter, has a mass 17 times that of Earth, and that, like Saturn and Uranus, it has a mean surface temperature of around -300 to -350 degrees Fahrenheit. It's worth noting that of all the 4 Jovian giants, only Jupiter itself shows any kind of real inner heat at 26,637 degrees Fahrenheit. Our Sun itself is around 11 million degrees Fahrenheit at its surface. But Jupiter is in many respects equivalent to a mini-sun when compared to its 3 giant but frosty companions, especially towards its interesting satellites. Neptune is also marked with a large blemish like the Great Red Dot of Jupiter, except that Neptune's is a great dark blue spot. Since both spots have similar characteristics, they're probably caused by enormous storm centers. However, Neptune goes one better than Jupiter in this regard, since it also has a lesser dark spot, which has a permanent bank of cloud covering its center. Neptune also possesses 8 satellites, the largest being Triton, which is 1,680 miles in diameter. It's still not known whether Neptune has a rocky core of any notable size, although it would be hard to imagine it to be entirely a gaseous orb. All that can be said is that its mean temperature in general is around -350 degrees Fahrenheit, and that it has a mass just under twice that of Earth. Starting from the outermost planet, Neptune, and heading sunward to the innermost terrestrial planet, Mercury, an odd fact seemed to emerge. As we look at the central rocky cores of all of them and ignore the thickness or thinness of their atmospheres, they appear to progressively enlarge in size up to Jupiter, which has the largest inner rocky core. Then, assuming there once was a big terrestrial planet where the asteroids now orbit, after Jupiter, the rocky spheres appear to taper down right again to Mercury. In general effect, what we would see in this view is a kind of cigar-shaped formation of planets. The encounter theory arose early in the 20th century as revisions of the old theories of French physicist George Buffon and the Americans Thomas Chamberlain and Forrest Moulton. In it, the infant Sun, then still an incandescent ball of cosmic matter, experienced an extremely close shave when it narrowly missed collision with a rogue star or meteor. The intruder passed by so closely that it drew out a long-curved, cigar-shaped filament of incandescent cosmic matter from the Sun. Although it remained connected to the rotating Sun by gravitation, this vast extrusion of matter then continued to whirl around the rotating Sun like a curiously shaped protruding arm. But as it began to lag the spinning Sun, it rapidly became a curved, trailing tail, rather like one limb of a rotating nebula. And as it did so, it gradually condensed into a string of discrete globules of white-hot matter, each more or less of a size relative to its original location in the cigar-like filament. Due to the different masses of the various planets and their correspondingly different orbital speeds, the planets soon became widely separated from their original orderly, in-line abreast formation, with result that the solar system became the scattered, willy-nilly disposition of planets along their respective orbits that we often see depicted today in illustrated astronomy books. As the eons passed and the planets began to form red-hot but solidifying crusts of rock, those nearest the Sun were inhabited by its fervent heat from cooling quickly and from forming dense atmosphere in the lighter gases, such as hydrogen, helium, and methane. The molecules of these were quickly agitated to escape velocity and boiled off into space by the intense solar heat. Venus was one of the few that managed to develop a thick atmosphere, since it was swathed in carbon dioxide and sulfur dioxide. Earth also developed and managed to retain a good atmosphere of nitrogen, oxygen, and carbon dioxide. But those further out, which received only a meager amount of the sun's radiance, were exposed to the deep cold of outer space. And whilst they were initially volcanically active, they began to cool down rapidly and develop deep atmospheres of those emitted gases that were best suited to such extreme coldness. Refrigerant gases such as ammonia and methane and other hydrocarbon gases were vented in great volume and burgeoned forth to form thick layers as liquids, crystals, and vapors. Since there was not sufficient internal or solar heat to boil them off into space, they continued to swell the planet's atmospheres into gigantic spheres of water, ammonia, and hydrocarbon vapors, acetylene, helium, and hydrogen gas. Thus, the great gas giants were born. The Sun, meanwhile, had by now become a thermonuclear fusion furnace and had begun to emit great bursts of blazing solar wind upon the inner planets, burning off their atmospheric hydrogen and methane. However, being so far from the Sun, the outer Jovian planets were able to retain their dense atmospheres intact as we see them to this day. Having now made this particular point concerning the Jovian gas giant atmospheres and described this curiously interesting theory of Jeans and Jeffreys, we should now leave this final theory at this point, at least for the present. As for Dr. Tom Van Flander's popular concept of Planet 5, the missing fifth planet, there is quite convincing evidence that there was once a largest planet orbiting either in the orbit now occupied by Mars or in between it and that of the main asteroid belt. This might have been the missing link between the terrestrial planets and the gas giants, and that it possessed the basic qualities of both types. In other words, it was a hybrid between Jupiter and Earth. This is especially true if one favors the close encounter theory, which was outlined earlier. If one subscribes to the possibility of an inhabitable interior world within that same planet, one will realize that not only would the atmosphere quite likely be much thinner, but that the gravitational pull of its hollow crust would also be considerably less. The implication of this is that it wouldn't be beyond the bounds of likelihood that creatures of almost, if not the same size and stature of those currently found on Earth, could have developed within the gentler gravity and lighter atmospheric environment of its inner shell. Proposed occupants of the planet's interior might have been technologically capable of not only predicting the coming catastrophe, but of escaping via its many portals in spacecraft of some advanced kind. They might even have already been passing in and out of their inner world on interplanetary missions for millennia before their world was destroyed. For all we know, they could have even already colonized Mars, the Moon, and even Earth. It would seem far more likely that they would have opted to colonize the interiors of those planets than their outer crusts. Let us not overlook the likelihood that at such a remote point in time, the Sun's heat and emissions of harmful radiations would have been far more powerful and dangerous than they are today. Of course, all this is very highly speculative, since we have no real evidence to support such a hypothesis, beyond the curious anomalies of the presently physically ruinous conditions of Mars and our Moon, not to mention the existence of the asteroid belts, for which there's no other really tenable explanation of origin than the totally shattering explosions of once existent planets. In closing, check out Tom Van Flander's excellent Exploding Planets hypothesis for further explanation on the origin of the asteroids and the past existence of solar system planets which met with untimely ends from whatever caused them to explode. Also recommended is The Scars of Mars by Don W. Patton for further views on this asteroidal formation topic, as well as that of the ruination of Mars by an exploding planet.